Hello everyone, welcome to Module 8, Lesson 3 of Mastering Ethereum. User interaction is a way a user interacts with a decentralized application. It encompasses everything from the user interface to the user experience. Enhancing user interaction is crucial for DApp success as it can make DApp more engaging, user-friendly, and ultimately more successful. This presentation will cover key concepts and strategies for enhancing user interaction in DApps. This presentation will cover a range of topics, including user interface, UI design, UX design, accessibility, and usability. We will now explore how to create intuitive and engaging DApps that will meet the needs of users. We will also examine best practices for designing DApps that are accessible to all users regardless of their abilities. Let us now look into some principles of good user interaction. The first one is simplicity. A simple and intuitive interface is crucial for positive user experience. Users should easily understand how to navigate and interact with the DApp and avoid unnecessary complexity and clutter. Consistency ensures a predictable and familiar user experience. Use consistent design patterns, navigation, and interaction throughout the DApp. This makes it easier for users to learn and use the DApp. Provide clear and timely feedback to users about their actions. This helps users understand the results of their interactions and feel confident using the DApp. Use visual clues, messages, or animations to communicate feedback. Accessibility ensures that the DApp is usable by everyone, regardless of their abilities. Design the DApp with features that cater to users with disabilities, such as screen readers, keyboard navigation, and color contrast. Let us now look into user interface design for DApps. A well-designed user interface is essential for DApps. It creates a positive user experience, making the DApp more engaging and user-friendly. A good UI helps users understand the DApp's functionality, navigate easily, and complete tasks efficiently. Several elements contribute to a good UI. Layout and organization ensure a clear visual hierarchy, making the DApp easy to navigate. A consistent color scheme creates a cohesive and visually appealing experience. Examples include designing a simple DApp UI with React. React is a popular JavaScript library for building user interfaces. It's well suited for creating DApps due to its component-based architecture, which allows for modular designs and reusability of UI elements. Let us look into an example for designing a simple DApp UI with React. To begin building a DApp with React, you'll need a basic project setup. This can be achieved using tools like Create React App, which provides a ready-to-use environment for building React applications. Once the project is set up, you can start creating UI components, such as the example shown below. This code defines a simple component that displays a welcome message and a button for connecting to a wallet. User experience or UX in DApps. User experience refers to how users interact with DApp. It encompasses everything from the user interface to the user journey. Usability is a crucial element for positive user experience. A usable DApp is easy to learn, understand, and use. Accessibility ensures that the DApp can be used by anyone, regardless of their abilities. Several strategies can be used to enhance UX in DApps. Implementing clear and concise instructions can help users understand how to use the DApp. Providing relevant feedback can help users understand the results of their action. Let us now look into an example of streamlining user registration. A streamlined user registration process is crucial for DApp adoption. Users should be able to register quickly and easily without being overwhelmed by the unnecessary forms or complicated steps. A good user registration process starts with a simple form that asks for only essential information such as username and email. Providing clear instructions and feedback is also important. Users should be able to understand what information is required and how to complete the process. Clear error messages and confirmation messages help users feel confident that they have completed the registration successfully. The example code below demonstrates a simple registration form with clear instructions and feedback. The registration form.js is a code that represents a simple registration form for users to input their name and email. The form uses React hooks to manage the state of name and email, allowing the component to update dynamically as the user inputs their information. When the form is submitted, a function logs the name and email to the console, simulating a backend call or any further processing that would occur in a real-world application. The form structure is straightforward, consisting of input fields for name and email, along with submit button. Each input field is associated with its state and updates the state based on user input. This component provides a clear and minimalistic user interface, aligning with the principle that users should be able to register quickly and easily without unnecessary complexity. The form also sets the stage for clear instructions and feedback, which are essential elements in creating a positive experience for users. Let us now look into enhancing accessibility in DApps. Accessibility in DApps ensures everyone can use your application regardless of their abilities. Accessibility is not just a legal requirement, it's about creating a better user experience for everyone. DApps designed with accessibility in mind are more inclusive and reach a wider audience. Several techniques can be used to improve accessibility in DApps. ARIA labels provide alternative text for screen readers, allowing users with visual impairments to understand the purpose of UI elements. ARIA labels can be added to form elements to provide additional context for screen readers. For example, a text input for users can have an ARIA label username to make it clear to the screen reader users what the input is for. This ensures that all the users can understand and interact with the form. Let us now look into an example of adding ARIA labels to make the form accessible. The accessible form.js code provides a form component designed with accessibility in mind, aiming to ensure inclusive user interaction, particularly for individuals with disabilities. The component uses useStateHook to manage the state of name and email as the user interacts with the form. This allows the form to update dynamically based on user input. The form consists of input fields for the user's name and email, along with a submit button. Each input field is associated with its respective state and updates the state based on user input. The label elements are associated with their respective input fields using HTML for attribute, improving accessibility for screen readers. Additionally, the area label attribute provides alternative text for screen readers, enhancing the understanding of UI elements for users with visual impairments. By incorporating these accessibility-focused elements, the accessible form.js code sets a strong foundation for creating an inclusive user experience within a DApp. The next crucial element is providing a feedback to users. Providing feedback is crucial for positive user experience. It helps users understand the results of their actions. It also makes the DApp feel more responsive and engaging. When users receive clear and timely feedback, they feel confident using the DApp. There are several types of feedback that can be used in DApps. Visual feedback uses visual clues such as color changes, animations, or icons. Auditory feedback uses sounds or tones to communicate information. Haptic feedback uses physical sensations such as vibrations to provide feedback. One common example of feedback is displaying a success message after a form submission. This message confirms that user's action was successful. It can be displayed as a simple text message or with a more engaging animation. The code example below demonstrates a simple success message using a pop-up message. Providing feedback to users after they complete an action is essential for good user experience. A success message confirms that user's action was successful, making the DApp feel more responsive and engaging. Let us look into this through an example. The registration form with feedback.js code exemplifies a user registration form that provides immediate feedback to the users upon submission, informing them that the registration was successful. The component uses useStateHook to manage the state of name, email, and submitted. This allows the form to update dynamically based on user input and triggers a submission confirmation. The handle submit function is called when the form is submitted. It prevents the default form submission behavior and logs the name and the email to the console. Additionally, it sets the submitted state to true, triggering the display of registration successful message. Upon successful form submission, the registration successful message is displayed, providing immediate confirmation to the user that the registration process was successful. By incorporating immediate feedback and clear instructions, this registration form aims to provide a smooth and reassuring experience for users, ensuring that they are promptly informed of their successful registration. The next component is using animations for better interaction. Animations are key for a better DApp user experience. They make DApps feel more interactive and engaging. Well-designed animations can guide users through the interface, provide feedback, and add visual interest. Animations can be simple transitions or complex keyframes. Transitions smoothly move elements between states, while keyframes allow for more complex animations. Micro-interactions are small animations that provide feedback or add delight. React's useRef and useEffectHook provide a great way to create animations. You can add animation styles to your components, then use useRef to target elements. UseEffect allows you to control animation timings and transitions. Animations can enhance the user experience in DApps. They make the interface feel more dynamic and engaging. A simple animation can be added to a button with a CSS transition. The animation will trigger when the button is hovered over. Let us now look into an example code of adding a simple animation in React. The animatedButton.js and animatedButton.css code snippets work together to create a button component with simple hover animation effect. The animatedButton.js defines a button with the text hover me inside it. The button has a class name of animatedButton, which is used to style with CSS. Component is a functional component in React used for rendering the button UI. The CSS file styles the button with the class name animatedButton. It sets the initial background color to #4CAF50, a shade of green, along with other properties like border, text color, padding, text alignment, and font size. The transition property is used to animate the background color change. The transition duration is set to zero point 0.3 seconds, indicating that the change will occur smoothly over zero point 0.3 seconds. The animated button hover selector specifies the styles that should be applied when the button is being hovered over. In this case, the background color changes to #45A049, providing a visual feedback effect. When the button is hovered over, the background color transitions from green to slightly different shade of green, creating a smooth visual effect. Overall, the code snippet demonstrates a simple yet effective way to add interactive elements to the user interface using CSS animations. The next component is implementing real-time features. Real-time features enhance user experience, they provide instant feedback and keep users engaged. The apps with real-time features feel more dynamic and responsive. Users expect immediate updates and notifications, leading to a more enjoyable experience. Real-time notifications are popular example. They inform users about events, updates, and changes in the DApp. Live updates for prices, transactions, or game scores are other examples. Real-time features create a dynamic and immersive user experience. WebSockets are technology for real-time communication between a client and server. They allow for bidirectional communication, enabling real-time data exchange. WebSockets can be used to implement features like chat, notification, and live updates in DApp. Real-time notifications are a crucial element of a great DApp user experience. They provide instant updates and keep users engaged. WebSockets are a powerful technology for creating real-time features in web applications. Let us now look into an example code of adding real-time notifications using WebSockets. The WebSocket.js provides a React component for handling real-time data through WebSocket connections. The component uses useStateHook to manage the state of messages, representing the notifications or data received through the WebSocket connection. The useEffect hook is employed to establish a WebSocket connection when the component mounts. Upon receiving a message from the WebSocket, the onMessage event is triggered, and a new message is added to the messages state using the setMessages function. Within the useEffect hook, a new WebSocket connection is initiated to specified URL. The socket.onMessage event is set to handle incoming messages and update the component state accordingly. The useEffect hook also returns a cleanup function that closes the WebSocket connection when the component is unmounted, preventing memory leaks or unnecessary resource consumption. The component's JSX code renders a div containing a heading for the notifications and a list of messages obtained from the WebSocket connection. Overall, the WebSocket component.js code enables real-time interaction in a decentralized application by leveraging WebSockets to establish a persistent communication channel for receiving live updates and notifications. Let us now look into enhancing security for user interactions. Security is critical for user interaction. Protecting user data and interactions is essential. Users must feel confident that their data is safe and secure. Implementing strong security measures builds trust and confidence in your DApp. Encryption safeguards user data. It transforms data into unreadable format. Secure authentication verifies user identities. Multi-factor authentication adds an extra layer of security. These techniques protect user interaction from unauthorized access. MetaMask offers secure authentication features. Users can log in with their MetaMask wallet. Their private keys are securely stored. This provides a secure way for users to interact with their DApps. Secure authentication with MetaMask. MetaMask offers a secure way to authenticate users. Users can log in with their existing MetaMask wallet. Their private keys are securely stored in MetaMask, eliminating the need for your DApp to handle sensitive information. To integrate MetaMask authentication, use the MetaMask provider injected into your DApp web page. Request user accounts using the ETH request accounts method. MetaMask simplifies the login process. Users can easily connect their MetaMask wallet. They can choose to connect to your DApp for specific actions, such as making transactions. This provides a user-friendly and secure login experience. The MetaMask login.js is designed to facilitate secure user authentication using MetaMask within a decentralized application. The component uses useStateHook to manage the state of account, which represents the currently connected user's MetaMask account. The Connect MetaMask function is triggered when the Connect MetaMask button is clicked. If the Windows.Ethereum object is available, a new instance of Web3 is created using the Windows.Ethereum object. The ETH underscore request accounts method is then used to request the currently selected user account from the MetaMask. Upon successful selection, the user's account is stored in the state using set account. The return statement of the component contains a div that renders a button labeled Connect MetaMask. When clicked, this button initiates the authentication process. If a user account is successfully obtained, a paragraph is rendered displaying the message Connected Account. In the event of error, such as the user denying account access, an error message is logged to the console using console.error. This component offers a streamlined and secure user login experience by leveraging MetaMask for authentication, allowing users to connect their MetaMask wallet to the DApp for secure interactions. Testing user interaction is another key feature. Testing user interaction is crucial for ensuring a high quality user experience in DApps. Through thorough testing helps identify, resolve potential issues before they impact users. It guarantees a smooth and intuitive flow, enhancing user satisfaction and trust in your DApp. There are different types of tests. The first one is unit test, second is integration test, and third is user acceptance test. These different types of tests address various aspects of user interaction. Unit tests focus on individual components, integration tests ensure components work together, and user acceptance test involves real users to evaluate usability. There are various tools used for testing. Zest is a popular JavaScript testing framework used for unit and integration tests. Cypress is a powerful tool for end-to-end testing, simulating user interactions with your DApp. Testing user interactions is crucial for building robust and reliable DApps. Zest is a widely used JavaScript testing framework, and React Testing Library is a popular tool for testing React components. These tools allow you to test user interactions and ensure that your components behave as expected. One common scenario is testing a button click. You can use the fire event.click method from React Testing Library to simulate a button click. Then you can assert that the expected actions occur after the click, such as triggering a function or updating the state of your component. Let's look into an example code of testing with Jest and React testing with testing libraries. The test code app.test.js is focused on rendering the connect wallet button and handling a click event, with a specific mention of asserting the button click functionality such as MetaMask integration. The test is designed to ensure that the connect wallet button is rendered correctly. It then simulates the click event on the button using the fireEvent.click function, triggering the associated functionality, which in this case includes the integration with MetaMask. The test leverages the art testing libraries of React to render the app component and interact with its elements, such as finding the connect wallet button and simulating the click event. Primary purpose of this test is to ensure that the button's click event triggers the expected functionality, which likely involves initiating MetaMask authentication or some form of wallet connection process. In summary, the provided test code is a part of an essential practice in software development where testing user interaction, especially in context of DApps, is crucial for ensuring the expected behavior and functionality of the application. This brings us to the end of our presentation. We have covered key aspects of enhancing user interactions in DApps. We have explored principles of good interaction, UI/UX design, feedback mechanisms, performance optimization, real-time features, and security considerations. Now let's open the floor for questions and clarifications. Feel free to ask about any concepts or challenges you have encountered on our Discord servers. Thank you and keep learning.